All right, so this video is going to be the first video about stereochemistry. In this one, we're going to talk about what is a stereogenic center, and then we're also going to discuss how do we assign RS designations for stereogenic centers and the steps to doing that. And so to start off, what is a stereogenic center? A stereogenic center is a carbon that is attached to 4 different groups. And so let's say that we have this molecule down here, we can take a look at one of these carbons here that I just drew a red dot over. And what we can see is that this carbon has 4 different groups. So it has a chlorine, a bromine, and then it has 2 different R groups going to the right and to the left. And so because those 4 groups are unique or different from each other, this is going to be a stereogenic center. In comparison to that, if we take a look at this carbon on the left, what we can see here is that if we were to draw in those hydrogens that are missing from the structure, we have 2 hydrogens bonded to that position. And so this one is not a stereogenic center because it doesn't have 4 unique groups. To be a stereogenic center, we have to have 4 unique groups, and 2 hydrogens are not unique. Next, we can take a look at this one in the middle. And so down here, with the carbon that's bonded to a bromine, we also have a hydrogen that we don't draw in skeletal structures. And so here we can see that we have 4 groups. So we have that hydrogen, the bromine, and then we have 2 different types of R groups going to the right and to the left. And so this is going to be a stereogenic center. In comparison to that, if we take a look at this carbon up here, what we can see is that we actually have 2 methyl groups bonded here. And so since 2 methyl groups are the same group, this is going to be not a stereocenter because we don't have 4 unique groups. And so even though it's not hydrogens, it's still the same group, it's still 2 methyls, and so it can't be a stereogenic center. Let's take a look at this final one. And so here on the end, we have an OH bonded here. And so if we were to draw in that hydrogen, we can see that we have 4 unique groups, the hydrogen, the OH, and then the 2 R groups going right and left. And so this is going to be a stereogenic center. In comparison to that, and this is a common mistake I see people make, is that this carbon right here that's double bonded to the oxygen only has 3 groups bonded to it. And so because it only has 3 groups, this can't be a stereogenic center. And that's because for something to be a stereogenic center, it has to have those 4 groups bonded to it. And so here we're going to not label that as a stereo center. All right, so why do we care about stereogenic centers? And so the reason we care about those is because they can create 2 different molecules depending on the orientation of the groups bonded to it. And so whenever we see a dashed group, that means that the group that's drawn in is facing away from us. Or in other words, it's facing into the page if we were to think about it in a 3-dimensional space. In comparison to that, a wedged group means that the group is coming towards us or out of the page. And so in a 3-dimensional space, that group would be oriented towards us. And so let's take this first molecule here that we were working with, and let's swap those chlorines and the bromines. And so we'll make the bromine wedged and the chlorine dashed, which swaps it from what it was in this initial structure. And so even though these 2 molecules look very similar, they have the same exact atoms bonded to the exact same positions, the difference in the bromine and the chlorine makes it so that these are not the same molecule. And so in the next video, we'll talk about how these are related. There's a word called enantiomers for them, and we'll talk about how to, there'll be a flow chart for how to identify if it's an enantiomer or not. And so let's say you're a chemist and you need to differentiate between these 2. The way you would do so is by using RS designation. And so the next part of what we're going to talk about is how do we use RS designation to describe what the 3-dimensional orientation of all the groups is at a stereogenic center. All right, so for this part, I'm going to use the exact same molecule to work through all these problems. I already have it drawn in over here. And so let's start off with step one. So in step one, our goal is to first identify the 4 groups that are bonded to the stereogenic center. And so here we can label the 2 stereogenic centers here in red, and I'm going to draw in those hydrogens so that we can know the 4 different groups. And so that one on the top has a hydrogen, a methyl group, and then 2 R groups that are different from each other. And then that bottom one has a bromine, a hydrogen, an oxygen, and then a other R chain. And so we have 2 stereogenic centers that we're going to be assigning R and S priority to. And so whenever you have 2, you do these independently. So I'm going to copy the molecule so that we have 2. And in the first one, I'm going to start with the bottom carbon, and then in this parallel one over here, I'll do the other one. So let's start off with this bottom carbon over here. And so for step 2, we want to assign priorities to the 4 groups that are bonded to that carbon. And so for this, we first look at the atoms that are directly adjacent to that carbon. And so here we have a hydrogen, and I'll highlight these. We have a hydrogen that's directly bonded to that carbon. We have a bromine that's directly bonded to that carbon, an oxygen, and then a carbon. And so we only care about that one removed groups. And so we have a carbon, a hydrogen, a bromine, and an oxygen that we're comparing. And so to assign the priorities, we then take a look at the mass of those atoms. And the lowest mass is assigned a priority of 4, while the highest mass is assigned a priority of 1. And so bromine is going to be the highest mass, so it's going to get a priority of 1. The oxygen is the second highest, so it'll get a priority of 2. And then this carbon over here will be given a priority of 4, and then the hydrogen as the smallest is going to be given a priority of 4. And so now we have 1, 2, 3, 4 assigned for that first carbon. Next, we can take a look at the structure on the right, which is the exact same. We're just going to be focusing on that top carbon here. And so here we have 4 different groups. And so we have a carbon, another carbon, another carbon, and then a hydrogen. And so here for this first step, we can't really compare the carbons. They all have the same mass. And so the only one that we can assign initially is going to be that 4. And then we'll have to use the other rules to assign the next priorities. So, okay, so we're good with this first carbon stereogenic center at the bottom. We have that one done. And now we need to wrap up this top one. And for this, we'll have to use rules 2 and 3. So for this, I'm going to copy over this molecule so that we're thinking about what are we assigning next. So for rule 2, if we have the same atom as in the case of this, where we have 3 carbons, we need to next look at the next door bonded neighbors of those carbons. And so this carbon on the left is bonded to a, oops. Sorry, let me get that back, that disappeared. Okay, so here we have that this carbon right here is bonded to 2 hydrogens and a carbon. So it's a carbon, hydrogen, hydrogen. And we write out those 3 atoms that it's bonded to. And we ignored the carbon that we initially came from. So that this one right here is also bonded to that red carbon, but we ignore the one that it came from. Next, we look at that methyl group going up. And so here, this one is going to be bonded to a hydrogen, hydrogen, and another hydrogen. And so that's going to be the next bonded groups for that one. Lastly, we can look at this carbon on the right. And so here we can see that this one's bonded to a carbon going down, and then it's also bonded to an oxygen. And then it doesn't have any other groups. It just has the carbon and the oxygen. And so we don't have 3 different atoms for it. And so to fulfill that one, we have to use rule 3, where we treat double bonds as if they're bonded to 2 of that same atom. And so we treat that double bond as if it's bonded to 2 oxygens. And so we add in another oxygen to that carbon there. And so now to assign the actual priorities, we can go back to what we had in rule 1, where we base it off mass, but now we just base it off, instead of the initial atom, we base it off the second order comparison. And so here we can see that COO is going to be higher than any of the others. And so this group right here is going to be priority number 1. The carbon, hydrogen is going to be priority number 2. And then that methyl group, which is the smallest, is going to be 3. And so usually this just follows with mass and how big the next door neighbors are. But that's not always the case. So I really recommend just drawing out those 3 atoms to do a better comparison. All right, so for step 3, we're ready to move on to step 3. So I'm going to copy over those same priorities again, just so we have them. And I'll redraw the priorities here. So we had 1 for the oxygen, 2 going here, and then 3 going up. All right, for step 3, what we're going to do is we're going to draw a circle from group 1 to 2 to 3. So starting with the 1 with the bromine, 2 to 3, we're going to draw a circle like that. And so what we can see is that when we draw this circle here, we're going in a clockwise direction. And so we're going to use an R designation. And one thing to note is that this is a preliminary designation. We're not done yet. We still have to do step 4. But for step 3, we're going to assign this as an R group. We can also do the same for this other group on the other carbon on the right. So here we're starting with 1, 2, 3. And so here we can also see that this is going to be an R group because we're going in a clockwise direction. And so again, this is preliminary. We're just thinking about 1, 2, and 3 for now. And before we finalize our answer, we have to do step 4. So for step 4, we look at the priority groups of number 4. And so number 4 in both of these cases is a hydrogen. And so we take a look to see, is group number 4 dashed or wedged? And so in this first one, let me copy this over again. In this first one, we can see that this hydrogen is wedged, and so it is not dashed. And so what we have to do is swap our answer. So we initially were R, but we're going to swap that to an S because that hydrogen is not dashed, or that group number 4 is not dashed. And so S designation will be our final answer. In comparison to that, if we take a look at this molecule, or the other carbon, I should say, because it's the same molecule. Here we were R. Here, what we can see is that this hydrogen, or group number 4, is dashed. And so we do not swap our answer. We keep it as R. And so our final designation for this other group is going to be R. And so if we were to redraw our molecule, starting from nothing drawn on it, I'll copy it from here over here. We would label this top one as S and this bottom one as R. And so the designation of those stereogenic centers would be S and R. And so we'd be able to compare it to other molecules that, or the same exact molecules, but with different designations. All right, so that wraps up how to do RS designation. In the next video, we'll talk about enantiomers and how to differentiate diastereomers from enantiomers.